students, myself Hital Shah from Major Instruct Engineering and Technology. Today we are going to discuss the subject probability and statistics. And today topic of the discussion is two-dimensional random variable, and in this topic we start with the two-dimensional continuous random variable. So a two-dimensional random variable is said to be continuous if it takes all the values in a specified region R in the xy plane, p of x minus dx by 2 less than or equal to capital X less than or equal to x plus dx by 2. And well, y is lies between y minus dy by 2 to y plus dy by 2 is equal to f of x y dx dy, right? So this is known as the two-dimensional continuous random variable. Now, the properties for the joint probability density function, and that is first property, and that is f of xy greater than or equal to 0 for all x and y. Number 2, integration minus infinity to infinity for both the integration and f of xy dx dy equal to 1. And the third and last, that is probability of x lies between a to b and y lies between c to d is equal to integration c to d and integration a to b f of xy respectively dx dy. So these are the properties of the joint probability density function. Okay. Now, this one, right? Now, the cumulative distribution function. So if xy is a two-dimensional continuous random variable, then f of xy for x and y is equal to integration minus infinity to y and integration minus infinity to x, f of xy dx dy is called cumulative distribution function of x and y. It is also known as CDF. Cumulative distribution function is known as CDF. Let's move for the next topic, and that is marginal probability function. So let x and y be a two-dimensional continuous random variable which assumes all the values in a specified region R in the xy plane. Then the probability distribution of x is given by f of x for all x equal to integration minus infinity to infinity f of xy dy, and is called the marginal probability density function of x. Similarly, f of y for all y, this is y, equal to integration minus infinity to infinity f of xy dx is the marginal probability density function of y. The next topic is conditional probability function. Let xy be a two-dimensional continuous random variable, then the conditional continuous density function or conditional probability density function of given y is equal to small y is denoted by f of x by y is defined as f of x by y is equal to f of x and y upon f y by y for all y. Similarly, the same conditional probability density function for y given capital X is equal to small x, and it is denoted by f of y by x, and it is defined as this. Got it? And a necessary and sufficient condition for the continuous random variable x and y to be independent, that is f of xy is equal to f of x for x and f of y for y. So these are the theory of the topics, and let's move for the some example for the better understanding. Here, our first question is the joint probability density function of a two-dimensional random variable is f of xy is equal to 1/2 x e to the power minus y, where x running from 0 to 2, x running from between 0 to 2, and y greater than 0, right? And equal to 0 otherwise. So find the cumulative distribution function. So here solution is the cumulative distribution function is given by f of xy is equal to integration minus infinity to y minus infinity to x f of xy dx dy. Right? Now, the limit for y is 0 to y because y is greater than 0, right? So 0 to y. And here 0 to x. So 1/2 x e to the power minus y dx dy. So here, if I keep 1/2 out of the integral, so 1/2 integration 0 to y. The integration of x is what? That is x square by 2. It is e raised to minus y, keep it same. X square by 2, right? And it is 0 to x. dy, keep it same. So 1/2, this 2 will be cancelled. So here 1/4 x square minus e to the power minus y 0 to y. So after substituting upper limit and lower limit, it is 1/4 e x square minus e to the minus y plus e to the power 0. So here 1/4 x square minus e to the power minus y plus 1. So f of xy is equal to 1/4 x square 1 minus e to the power minus 1 when 0 less than x less than 2 and y greater than 0 and equal to 0 otherwise. Okay. Let's move for the next question, and that is the joint probability density function of a two-dimensional random variable is f of xy is equal to x e to the power minus x in the bracket y plus 1 where x greater than and y greater than 0, and examine whether the variable x and y are independent. So the solution is f of x for x is equal to integration minus infinity to x in a minus infinity to infinity f of xy dy, right? So here 0 to infinity, because x and y both running from 0 greater than 0. So 0 to infinity, and my function is x e raised to the power minus x y plus 1 into dy. So x, keep it same, integration of e to the power minus x y plus 1. We are doing integration with respect to y, so upon minus x, and limits are 0 to infinity. So here x is cancelled, and if I keep minus sign out of the bracket, e to the power minus infinity minus e to the power minus x, right? So after simplification, e to the power minus infinity is 0. So it is e to the power minus x, where x is greater than 0. Similarly, if I do for y, and that is f of y for all y, that is minus infinity to infinity f of xy dx, right? Now, as you know, x and y both greater than 0. So here 0 to infinity, and my function is x e to the power minus x y plus 1 dx, right? So here integration is what? X, keep it same, e to the power minus x y plus 1 upon minus y plus 1, derivative of x with respect to x is 1, and e to the power minus x y plus 1 upon y plus 1 whole square. and limit are 0 to infinity. So if I put infinity, my both first term is 0 because e to the power minus infinity is 0. And if I put 0 in this place of x, so here x is 0, so 0 into anything is 0. So only last term is there. So here 0 minus 0 minus 0 minus, if I keep here 0, e to the power minus 0 is 1. 1 upon y plus 1 whole square, right? So my final answer is 1 upon y plus 1 whole square, where y greater than 0. So this is the answer for the f of x for all x and f of y for all y. We want to check whether the variables x and y are independent or not, right? So for that, here f of x for all x dot f of y for all y is equal to the value of f of x for all x is e to the power minus x, and this one is 1 upon y plus 1 whole square, right? So here f of xy is equal to x e to the power minus x y plus 1. So f of xy not equal to fx for all x and f of y for y, right? Hence, x and y are not independent. Okay, let's move for one more example, and that is two random variable x and y have the joint PDF f of xy is equal to a e to the power minus 2x plus y, where x and y both are greater than or equal to 0 and equal to 0. Otherwise, you have to find the value of a first, then marginal PDF of x and y, and f of y by x. So let's start the solution, students, and that is here. Since f of xy is a PDF, right? So as per the rule of the PDF is what? See here, as per the rule of the, it is satisfied this probability. And as per this probability, integration minus infinity to infinity, uh, again in integration minus infinity to infinity, f of xy dx dy is equal to 1. So as f of xy is a PDF, so it satisfies the property of integration minus infinity to infinity f of xy dx dy is equal to 1, right? As you know, x and y both are greater than or equal to 0. So 0 to infinity for both the integration, a to the a into the power e to the power minus 2x plus y dx dy is equal to 1. So if I keep a out of the integral, 0 to infinity, in the integration 0 to infinity e to the power minus 2x dx e to the power minus y dy is equal to 1. So a integration 0 to infinity is e to the power minus 2x upon minus 2. Limits are 0 to infinity e to the power minus y, keep it same, dy is equal to 1. So after simplification, here a by 2, a by minus 2, integration 0 to infinity e to the power minus infinity minus e to the power 0 into e to the power minus y dy is equal to 1. So a by minus 2, right? Here integration 0 to infinity, here minus 1 e to the power minus y dy equal to 1. So a by 2 e to the power minus y upon minus 1. So into minus 1 0 to infinity equal to 1. So after simplification, it will become a by 2 minus e to the power minus infinity plus e to the power minus 0 equal to 1. So my final answer is a equal to 2. So this is the first answer, a equal to 2. For the second one, here f of x for x equal to minus infinity to infinity f of xy dy, right? And it is 0 to infinity a e to the power minus 2x plus y into dy. So if I keep here a is 2, right? So if I keep 2 out of the integral, it is minus e to the power minus 2x plus y. So limits are 0 to infinity. This one is 2. We are doing the integration with respect to y now, right? So here 2 minus e to the power minus infinity plus e to the power minus 2x. So final answer is 2 times e to the power minus 2x when x greater than or equal to 0. Same for f of y for all y, and that is minus infinity to infinity f of xy dy dx, right? So here integration 0 to infinity a e to the power minus 2x plus y dx. If I keep 2 out of the integral and integration of this with respect to x, that is e to the power minus 2x plus y upon minus 2. And the limits are 0 to infinity. So this 2 will cancel, only minus sign is there. So here e raised to minus infinity minus e to the power minus 0. So my final answer is e to the power minus y here, right? So minus minus plus, so e to the power minus y, where y greater than or equal to 0. So f of y for all y is equal to e to the power minus y, where y greater than or equal to 0 and equal to 0 if y less than 0. So this is the answer of the second question. And for the third one, we want to find the value of f of y by x, and that is f of xy upon f of x for all x, and that is 2 e to the power minus 2x plus y whole upon 2 e to the power minus 2x. For simplification, it is e to the power minus y for all y greater than or equal to 0. So this is the answer of the given question. Got it, everyone? So feel free to contact me for any query. Till that, enjoy the study. Thank you.